In this lecture, I'm going to provide a background and a summary of the scientific method. Now, the scientific method is the foundation for which we conduct statistical analyses. And so when we think about the scientific method is a systematic process that incorporates two basic types of logical reasoning, and that's inductive and deductive reasoning that I'll detail here on the next slide. The scientific method is characterized by being a very systematic and a very controlled process. And the reason that it is systematic and controlled is because we wish to attribute the findings or the results of a study back to the way the study was conducted. And doing so means that the scientific method involves a series of events, a sequence of events that can be replicated. And the scientific method is incorporated if we want to take an empirical approach. So once again here, when we talk about an empirical approach, we're not talking numerical values. We're talking about an approach where we obtain data or simply information objectively through direct observation. Now, this could be done qualitatively, where we don't apply numerical values to our observations, or we do it quantitatively, where we do apply numerical values to our observation. A key critical step to the scientific method in conducting an experiment is the concept of control. And what control basically does is it allows the experimenter to control factors that could interfere with the study so that the study is conducted in an isolated manner to address the research question that is posed. And so, as indicated, the concept of control is a general concept that can be implemented a number of different ways in an experiment. And some of these ways include randomly assigning different cases in a research study to different conditions, matching different groups based on some sort of characteristic that the researcher defines, or a concept called blinding or masking. These are two terms that are used interchangeably, which means that the researcher and or the research participant is not aware of a particular condition that is being applied to the research participant. And this is often used in drug studies or studies that investigate some form of medical treatment for some sort of condition. And so when we think about the scientific method, it's in a general sense, but we're getting a little bit more specific here with respect to the sequence. It often starts with deducing a question from theory. So as indicated on the first bullet item of the slide, where we apply logical reasoning, specifically inductive and deductive reasoning, we typically start with deductive reasoning, where we generate a research question from some general theory. And from that general theory, we arrive at a very specific question we want to ask. And once we have that research question, we design the experiment in which we collect information and we analyze that information. And it's a direct answer to a direct question that was generated in step number one. So once again, I use the term data here to indicate that we're collecting information, and data could be qualitative or quantitative, but in this course we're going to refer to that as quantitative data. And then once we have the analysis completed, the statistical analysis, we have to interpret the findings, and we apply the opposite to deductive reasoning, which is inductive reasoning. And so we then take those findings of our analysis and we arrive at a general statement that goes back to the population. We arrive at some general conclusion that can be applied to a much larger base than just the sample we collected. And so the method of the two approaches here with logical reasoning, deductive and inductive reasoning, are going to be summarized here in these two flow charts. And so what we try to do here with these approaches is that we want to apply logical reasoning to come up with a solution to a problem or an answer to our research question. And we'll start here on the left-hand side with deductive reasoning. And so when we think about deductive reasoning, I'll come back to the research design and execution here shortly. I'm going to start with an example. So as it mentioned on slide 12, we have some theory, perhaps a general observation. So we start very general and we get very specific with deductive reasoning. And so from a general statement, we generate a research question. As an example, we have the general theory that dementia increases into older age. If that's our general observation, then if I were to take this and apply it to a very specific case, then I might conclude that because my grandfather is an older adult, my grandfather must have dementia. Now, the accuracy of my final statement is predicated on the accuracy of the general observation or theory. So although we might take the correct steps in getting to our specific conclusion, if the general observation or theory is flawed, using solely deductive reasoning, even though we take very clear and correct steps to get to the conclusion, our conclusion will still be inaccurate if our general observation is inaccurate. On the right hand side, we're going to demonstrate inductive reasoning, and as opposed to deductive reasoning, which started with a general observation, inductive reasoning starts with a very specific observation, and based on the specific observation, we then use inductive reasoning to arrive at a general conclusion. And so to use the same example here, if I make a very specific observation that my grandfather has dementia, I might therefore conclude that all older adults must have dementia. So you can see a very similar pattern here, that if we rely solely on inductive reasoning, that I might arrive at an inaccurate or incorrect conclusion that all older adults must have dementia. And so when we talk about research design and execution, the scientific method is an application of both techniques, where we start on the left-hand side, where we use deductive reasoning to generate a specific conclusion, and that specific conclusion would be a research question after we've reviewed much of the theory, and then we take specific observations from a sample, and from that we might arrive, or we would arrive at a general conclusion that we would apply back to our first general observation on the left-hand side. And the general observation is applicable to the population. Then we move in towards the sample. With inductive reasoning in executing the experiment, we make a number of observations, specific observations on our sample, and we arrive at a conclusion back to the population. And so the general overall scheme here with experimental design and conducting an experiment is really an exercise in logical reasoning. Just some other key elements here to consider when thinking about the scientific method. The scientific method is all based upon making an observation. Now that observation could be qualitative or quantitative. If it's quantitative, then we follow a very specific set of procedures to analyze those numerical values. when we make that observation, before we make the observation, we formulate a research question and we generate the educated guess based upon our reading, based upon our knowledge of the theory, previous research, and we come up with a research hypothesis. And so once we have that educated guess before we've made any of the observations, we then conduct a process where we design the experiment. This is the first element of the research trinity, where we lay the plan and then have a solid plan that lays out our approach to answering the question. Once we have that approach designed, we can then execute the experiment. We run the procedures, and once we've collected the information, we analyze the results. And this is where we provide a direct answer to a very direct question. And the most challenging part to conducting an experiment is drawing conclusions from the data. And this is where we need to interpret the results back to the reasons why we formulated the question to begin with and how that compares to our educated guess. So after we've completed an experiment, we drew some conclusions from it. This oftentimes will lead to the formulation of a new hypothesis and a new research question, which then continues the research cycle. Where the end of one experiment is not necessarily the terminal end of the process, but it sets up for the next experiment to be conducted. And although that oftentimes this is a most utilized approach in formulating a new hypothesis, an important element to research is replication. But unfortunately, in the scientific world, replication studies are very, very few. And a replication study is replicating the exact same experiment, usually by a different group of researchers. And then if they arrive at similar results, then that provides greater confidence and faith in the answer generated to that research question. And so just one last slide here. When we think about the scientific method, some of the key elements that the researcher is recommended to apply and to retain when using the scientific method is a degree of skepticism. And so the researcher might have great confidence in their work and the methods that they applied. There should always be a degree of skepticism in the final results, and that will drive the researcher to always want to find a deeper answer and to ensure that the answer is valid. Doing so requires the researcher to maintain an open mind to the possibility that they could actually be wrong, particularly when it relates to the research hypothesis. Viewing the scientific method as a business approach is necessary to maintain objectivity. And so this top right-hand quote here is from a famous 1950s police detective show where the detective would just say just the facts. And that's really what the scientific method is all about. It's about just the facts and maintaining objectivity. And particularly when it comes to statistical applications, understanding empirical research versus non-empirical research will guide the researcher into what specific methods are needed to analyze the information. Once again, the empirical approach refers to research that has the researcher making a direct observation, whereas non-empirical research, sometimes referred to as theoretical research, does not involve a direct observation of a case. Although the scientific method is a very clean-cut approach and very objective, the researcher can still implement a degree of creativity in developing the experiments. And the final stage of the scientific method, very important stage, is communication. The researcher can have the most groundbreaking results of an experiment, but if the researcher cannot communicate those results to the scientific community or to the general public, the results of the findings will not be particularly useful. And the last point here is that replication is a very key element that is not done enough in the scientific world. So this video is just going to leave you to read these two quotes from two very famous Nobel Prize winning physicists in terms of their views of the scientific method. So this ends this lecture on the scientific method.